This is the polished unified version. The Firmament Handbook Hydrogen Layer Formation Fully Completed Edition. Number 1. Rising gases naturally sort themselves into layers. In any atmospheric system, gases rise or fall according to density. Hydrogen, the lightest element, ascends through the atmosphere more efficiently than any other gas. As it rises, it passes through the troposphere, stratosphere, mesosphere, thermosphere, and exosphere. Each layer has distinct temperature, pressure, and electromagnetic conditions. These gradients act as a natural sorting mechanism, guiding hydrogen into regions where different physical states become possible. This upward migration is the first step in the formation of the hydrogen layer firmament. Number 2. Hydrogen heats as it rises, despite cold ambient temperatures. As hydrogen ascends, the surrounding air becomes colder, but the hydrogen itself becomes hotter due to direct exposure to solar ultraviolet radiation, charged solar particles, geomagnetic field lines, auroral currents, ionizing collisions. In the upper atmosphere, gases experience low pressure and high radiative absorption, causing their kinetic temperature to rise even when the ambient air is extremely cold. This is a known phenomenon in thermospheric physics. Low-density gases can reach temperatures of hundreds to thousands of degrees due to radiation absorption. This combination of low pressure plus high energy input begins altering hydrogen's electronic structure. Number 3. Hydrogen transitions into metallic gas under radiative and electromagnetic excitation. As hydrogen continues upward, the combination of decreasing pressure, increasing kinetic temperature, electromagnetic excitation, partial ionization causes hydrogen atoms to enter a metallic gas phase. In this state, electrons become partially delocalized, allowing hydrogen to behave like a conductive medium. This metallic gas forms a continuous fluid-like layer suspended above the conventional atmosphere. This transition does not require gravitation or compression, as in gas giants. It is driven by radiation, ionization, and electromagnetic confinement. Number 4. Metallic hydrogen gas becomes a plasma layer at higher altitudes. Further upward, hydrogen encounters even stronger solar wind, geomagnetic currents, ionizing radiation, auroral particle streams. These inputs fully ionize the metallic hydrogen gas, transforming it into a plasma layer. Plasma is electrically active, light-responsive, and capable of carrying large-scale electromagnetic currents. This layer is responsible for auroras, electromagnetic wave guiding, upper atmospheric glow, optical distortions, the luminous behavior of the sky. The plasma zone forms the active, dynamic interior surface of the firmament. Beneath the plasma, hydrogen condenses into liquid metallic hydrogen. Below the plasma layer, temperatures remain high but stable enough for hydrogen to condense into liquid metallic hydrogen. This phase is known from high-pressure physics that can also form through electromagnetic confinement and radiated heating. Liquid metallic hydrogen behaves like a reflective fluid, a conductive metal, a continuous membrane and self-supporting shell. The layer provides the structural backbone of the firmament, acting as a planetary scale conductive sheath. Number 10. Above the plasma, hydrogen cools into crystalline hydrogen. At the highest altitudes, near the cold vacuum of space, hydrogen loses energy and transitions into crystalline hydrogen, a rigid, transparent ice-like lattice predicted in low-temperature physics. This crystalline layer becomes the outermost shell, the optical boundary, the surface that refracts and reflects light, the structure that produces star-like points and celestial patterns. It is the solid-state cap of the firmament. Number 7. Atmospheric layers support the entire hydrogen phase stack. The Earth's atmospheric layer naturally create the conditions needed for each hydrogen phase. Troposphere, mixed gases, water vapor, weather. Stratosphere, stable gradients where hydrogen begins separating. Mesosphere, cooling zone when metallic gas transitions begin. Thermosphere, ionization zone leading to plasma formation. And exosphere, near vacuum where crystalline hydrogen can form. Each layer provides the temperature, pressure, and electromagnetic environment required for hydrogen to transition into its next state. Number 8. The firmament is a vertically stacked sequence of hydrogen phases. From bottom to top, the structure forms a continuous self-organizing system. 1. Hydrogen gas layer. 2. Metallic hydrogen gas layer. 3. Plasma hydrogen layer. 4. Liquid metallic hydrogen layer. 5. Crystalline hydrogen shell. This sequence creates a thermodynamically stable, electromagnetically supported dome. 9. Why the structure is physically plausible. The firmament relies on well-established physical principles. Hydrogen naturally rises and sourced by density. Hydrogen has multiple exotic phases. Plasma and metallic hydrogen are experimentally verified. Crystalline hydrogen is predicted by low-temperature physics. Electromagnetic confinement can stabilize high-energy materials. Atmospheric layers provide the necessary gradients. Solar heating and space cooling create natural phase transitions. Together, these mechanisms form a coherent, scientifically grounded explanation for a layered hydrogen firmament.